so the first part of what we're doing today is going to be dividing radicals and simplifying when dividing radicals. So we have this thing in math where we do not like the denominator to be an irrational number. Is square root 3 an irrational number? The square root of 3 an irrational number?
Yeah.
Yes, it's irrational. So we do not want that square root 3 in the denominator. It's just this weird rule. I'm sorry. No more explanation other than that. You may have seen it in geometry. Irrational means so any number that's not rational. So yeah, you couldn't write it as a fraction. That's right. Very good. Fraction ratio of 2 integers. Could not. So any idea what we might do to get rid of that square root or radical in the denominator?
What?
And so when we multiply, we would have to multiply both the top and bottom by something. What is it that we multiply the top and bottom by? Square root of 3. Good. Because square root of 3 over square root of 3 equals, what does that equal? Square root of 3 over square root of 3? 1. So that's like multiplying it by 1. So someone in one of my other classes said, well, what if we square it? Can't square because there's no other side to square, so that would change it. But if we multiply top and bottom by something, it's like multiplying it by 1. So on the top, we get 7 times square root 3. What is the square root of 3 times the square root of 3? I hear a couple of you going right there to the answer. Some of you go to 9. Square root of 9. What is the square root of 9? 3. So it's going to be the square root of 9, which equals 3. Or if you can go straight to 3, that's even better. Does that make sense that that equals 3? So now that denominator is rational and we're good. That's as far as we go. And I know it looks like that's not necessarily more simplified, but again, we just don't want that radical in the denominator. If you go on to a class after this, that's what they're going to expect you to know, that you can't have that radical in the denominator. Okay, so I'm going to call in a group. Problem number 2. Ariel, your group. What would we do to get rid of that radical in the denominator? Good. Multiply top and bottom by square root 5. And so what do we get when we do that? 4 square root 5 over 5. That's right. That's it. Why can't we do any canceling with this 5 and this 5 that's inside the radical? One of them is inside the square root, one of them is not. I can't do any canceling there. If they're both in a square root, I could do some canceling. Or if they both were outside, I could do canceling, but not when one is and one isn't. Does that make sense? Okay, so another group. This group here. Tell me what we would do on number 3. Yes, multiply top and bottom by square root 7. This one's just a little more complicated. What do we get in the denominator? Yeah, 7. And then what would we get on the top? Can we get somebody besides Armani to answer that question? What would we do with that square root 3 and square root 7? Simpler than you think. We just multiply the square root 3 and square root 7, and that gives us square root 21. So we leave the 3 on the outside. It's 3 square root 21 over 7. And again, this is inside a square root. This one's not, so there's no simplifying that we can do. Okay, so not too hard, huh? Okay, what would we do on number 4? This group back here. That's right, on top and bottom, numerator, denominator. So what do we get on the bottom? Very good. So he went right to 18. I'm going to write out the steps, but if you go to 18, you see that it's 18, that's great. So on the top, we're going to take 10 times the square root of 7 times 6, which is 42. And then, as Noah said, square root of, or 3 times 6 is 18. So we want to look at that 42 and see if it can simplify. We did prime factors of 42 using a factor tree. Are there any pairs that go? It's just 7 and 6, isn't it? And so there aren't any pairs. So what can simplify though here? Yes, what goes in about 10 and 18? 2, so this is 5 and this is 9. So it's 5 square root 42 over 9. Okay. Do you have a question on that?
No, I just didn't notice. What we simplify by?
So we took a 2 out of the 10 and the 18 because they're both outside the square root. Okay. You are going to have to do one where you simplify on your homework assignment. So I want you to, on your whiteboard, if this is not on your paper, simplify the square root of 18 for me. On your whiteboard, simplify that. We've done that before.
It's not like a simple.
Just say it. Just say it.
Just say it. Just say it. It's like yeah. Yep. Number 5.
You simplify square root of 18. Oh. So that would simplify to 3 square root 2. Does that make sense?
Yeah.
Okay. Okay, go ahead and do number 5. This is your you try number 5. I need to leave that up there. Is that what you left? I'm sorry. Does that make sense? Okay, so you should get an answer of 4 square root 15 over 9. Okay, so this is leading up to the stuff that we're going to do today with this. So we're going to find some trig functions. So this is cosine theta. This question, does it ask me to find theta or does it ask me to find cosine theta? Cosine of theta, which is different than finding theta, isn't it? So cosine theta cosine of theta, cosine is adjacent up over hypotenuse, right? So I'm drawing a little person here, where the theta is. What is, this group here. What is 4 square root 14 in relation to the theta? Adjacent. And what about the 18? Hypotenuse. So we have the adjacent and the hypotenuse. So the adjacent is 4 square root 14. And the hypotenuse is 18. Are we fully simplified?
No.
What can we do?
Divide it.
We can take both, and 4 and 18, we can take out a 2. So this becomes 2, this becomes 9. So this is 2 square root 14 over 9. Does that make sense?
Yeah.
So once again, why don't I, at this point, take the cosine inverse of that 2 square root 14 over 9? We are finding that trig ratio of cosine theta. Do you understand the difference? Because it's really easy to get them mixed up when we put them together. Okay, so we are finding tangent theta on number 7. Tangent is opposite over adjacent. So here's theta. Cohen, your group. What is opposite from theta? Is that side given?
No.
It's not. What about the adjacent side? It's the 9. So we're going to need the opposite side. So any idea what we might do then to find that opposite side? Good. We're going to use Pythagorean theorem. A squared plus b squared equals c squared. Which part of Pythagorean theorem, which letter is your hypotenuse? Which letter? Which one? C is your hypotenuse. So the 10 is your C. And then the A and the, doesn't matter which one you make A, the B or the A, doesn't matter. And then so we're going to say a squared plus b squared is 10 squared. So this gives us 81. And what would we do next? This group again, what would we do next to find out what b squared is? Yep, minus 81. Okay, b squared is 19. And then what next? Square root. And so what is b? Square root 19. So we found this side to be the square root of 19. We are finding the tangent of theta. The opposite would be square root 19. The adjacent would be 9. Do we need to simplify that anymore?
No.
Nope, we're done. What's that? Yeah, you can't on 19. You want to if you can, but we're leaving it exact. Yeah, unless it's a number that's a whole number. Okay, we'll do one more, and then I'm going to have you do number 9. Okay, number 8. Reston, your group here. We want to find tangent again, and that's opposite over adjacent. So in your group here, here's your person. Which is the opposite side? 9. And then what about the adjacent side? It's not given. So here's our adjacent. So what do we do to find that adjacent side? Because we're going to need it to find tangents.
9 squared plus b squared equals 9 squared.
Good. So the C is 9 square root 2 squared, and then we have 9 squared. You went straight there. Good job, Will. So our 9 square root 2 squared, I'm going to do this over on the side. Nine times 9 is 81. What's square root 2 times square root 2? 2. So 81 times 2, which is 162. So we get 81 plus b squared is 162. What next?
Subtract 81 on both sides.
Subtract 81. So we get b squared is 81.
And take the square root on both sides.
Yeah. So what's b?
9.
9. So b is 9. Also, so tangent, which is opposite over adjacent, is 9 over 9. What does 9 over 9 simplify to? 1. So tan theta is 1. Go ahead and do number 9 as your U try. I'll come around and check that.
You know, Mike.
I'm gonna hold off a second.
No, I just want to leave in this space.
So aren't you doing number 9 right now?
I can see it. I think it's so You got snacks? Got food? Oh, I got food. You actually like drinks, like, you actually like dress up for it today? Yeah, right? Yeah, but I got 30 songs in the way to and then the pass half a sports card would be signed, the pass that around, and I have a shoes on for the shoes. I'm in the damn classroom. Who's gonna see it? Yeah, how is it gonna steal it? Rusty's gonna steal it. How's that?
Yeah, I thought that was.
I go back now. Good job. This you don't have a final stuff.
You almost there.
Never 94, no.